How about now? Silent C on is now. Sorry about that. Wow. I did a bit of Did a bit of rearranging today to be able to. Basically, I moved all my camera equipment from this side all the way over to this side, so I can be near my scope. And yeah, I had to plug everything back in again, and I plugged something into the wrong port. Sorry, my bad. So hi everyone. Got a lot of folks already here, which is awesome. So I'm still just moving my desktop around. It's early. So let's say a quick hi to everyone. See who's in the stream, shall we? Lots of chatter before I got here. So of course, Michael, good morning. And Mike, wow, you're up early. Adam, good morning. The Embedded Hobbyist, hello. This scrolling thing is really frustrating. Excuse me. Tabletronics, hello. Mad Labs, Hippotronics, lots of tronics. The account formerly known as Crazy Cashier. Hey, crazy boy. Crazy Roops, hello. Good morning. Death Shaker, hello. Swirling. And Johnny, hi. G'day, Ian. Hey, Graham. Hey, Paul. And David. And Philip. And Christopher. They're waiting for 100 before he turns up. For 100 what? 100 people watching or on the stream? Nah. Hey, Azzy. Hey, Tiny LED Matrix. Hi, Ian. Hi, Peter. Hey, Andy. And Shaq. And Yaz. Hi, Yaz. I think the kids are watching. G'day, Ryan. Hi, DC Allen. And Christos. And Jay. Wow. Gert, good morning. IVH, hello in Denmark. Michael, Hyde, Rat Madness. Matt Radness. That's actually, there you go. So it's Matt. That makes sense then. Hey, Chris. Hello, James. Another David. Oh, wow, too many. I'm going to have to start saying hi to everyone by their surname as well. Lots of Davids and Jameses. Hi everyone. Sorry, that was a list to go through. Wow. So before I forget, I wanted to let you all know that my kids are starting a new school today. So they're back at school as of this morning. They haven't left yet. They're starting at a brand new school. So I just wanted to wish them well. Have a great day at school, guys. Hope your first day is awesome. Hey, Jet Gyrotech. New school. It is exciting. It is. Everyone's nervous, but it's going to be they're going to have a great year. It's going to be a great school. All the Davids, yeah. Hello, Americo Luis. If I pronounce that correctly, don't know. Hey, Bruce. Thanks, everyone. No, it's not a maker school. To be honest, I don't think they've got a maker space at all at the school. They're not. It's a very small school, and they're really just ramping up, and so they're But we think it's a really good fit for the kids. So yeah. Okay. So I'm just warning you all now. I think I say this every stream almost. I'm super tired. I got very little sleep last night, so I'm likely going to make some mistakes today. Most definitely going to slur my words. Hopefully I won't spill my coffee on my keyboard. Well, yeah, more coffee. Here, kids get ski days off. Really? Wow, how cool would that be? Did I get my MCP 23017 working? I did. So I ended up, for those of you that don't know, last stream, or didn't catch the last stream, I was working on getting the MCP 23017, which is a GPIO port expander, working with a Raspberry Pi. And I was trying to use the Adafruit Blinker translation library with their CircuitPython MCP library, and I couldn't get it working. And then I tried to use the SM Bus version, and it kept failing. It turns out that the SM Bus version I had was wrong, but it wouldn't update it or change it. And what I ended up doing is just removing a whole bunch of stuff and then reinstalling from scratch, and everything worked. So I got SM Bus working, and then I've started working on my own wrapper to wrap that. And Mike helped me out with that, Mike Corso. So yeah, that was great. So that issue is solved. Since then, I was actually speaking to Philip Tyrone from Adafruit, and they've been working on lots of fixes over the last week and stuff for Blinker. So Blinker's it's a moving goalpost thing for them, right? Because it's the glue for a lot of their stuff. They're constantly having to update it and fix it and tweak it. They invest a lot of time and effort into it, and they put there was a lot of fixes that went in over the last week, and it looks like the issue I had has been fixed. I haven't tried it though, but I've got a solution either way, which is really good. Why not light clear switches from the bottom? Why not light clear switches? What is that in reference to? Hey GK, light clear switches from the bottom. I'm not sure if that was for me. Teach some skills. Global system has been totally commercialized. Our education system here hasn't been commercialized, or not in the primary school area, but it's they are downscaling to a new, much smaller school. So and because of that, they've got less resources. But there's other stuff that's really important for us. It was in a chat. Oh, right. Okay, cool. No worries then. I just didn't know what it was for. I'm heading to the asylum. Bye, Yaz. Good luck. Say hi to the inmates. So yeah, that's really cool. That was done. So I have obviously a lot more work to do on that, but it's still a bit early for me to finalize a test jig for the Pro S2 because I still don't have silicon. Yeah. Okay. It's getting there. They're progressing. Hey, Christian. So, what else have I got to tell you all? I do have a surprise unboxing I'm going to do later today. So please remind me if I forget. It's kind of exciting. It was a swappy. I did a swap between with Radomir with Dishepu. So yeah, that's I'll show you what I got. That'd be cool. But later. So after the MCP adventure, I started looking at the 25-cent per hook microcontrollers. They look like they could be neat, intelligent I/O expanders. Yeah, look, there's actually a lot of options for I/O expanders. It's actually insane how many there are out there now. But I'm just really comfortable. Like, I've used the MCP so many times, and you know, it's not the most feature-rich chip out there in terms of its capabilities, but what it does really well. It's really reliable, and you know, it's got, I mean, stuff I'm not going to be using. It's got full interrupts and, you know, full bank control for port A and port B and stuff. But yeah, I just, all I need for me is to be able to switch a whole bunch of I/O on, set them to high, and then read the result at the other end. Right? That's it. The most basic of things ever. So, and I could definitely use like a level shifter or something instead, but I'd have to fire that one at a time, where I just want to be able to hit the whole thing at the same time. In resourcing has been shown to not result in improved outcomes, aka super high resourced private schools do not statistically get better results. Yeah, I agree, Ian. Like, I'm a strong believer that let me clarify that I think schools are very important for sure, but I think school has become less important from an educational point of view now because kids are learning outside school rapidly. Like my kids are learning more off their iPads and off their, through the internet and what they're exposed to at a pace that's like 1,000 times faster than I did when I was young, right? I had to rely on school and on textbooks when I was young, and that was the only way that information was disseminated, right? Where it's totally different now. So school's got a lot of other... The benefits of school is for me, is less in the education side and more on the social and the team building skills and the interaction side, right? Stuff like that. And I think those type of things are, a lot of those things you learn just by being in that space, I think. But I don't know. I no idea what I'm talking about. I knew the school was super important. Learning to learn is the biggest thing. Being curious, absolutely, yeah. Teaching someone to be curious and ask questions is far more important than teaching someone to remember data out of a book. So, and I'm terrible at that, right? I was the worst student. I think we've covered that before. I was a very bad student. Yeah, Ian and I agree for the most part. We agree a lot, actually, Ian. There you go. I'll come in and talk about schools on my stream. Okay, well, when you start up your own channel, Yaz, and start a stream, you can definitely do that. Important question, if I hook up a GSM modem with Tiny Pico, is there a way to update the firmware over the... I don't believe so, no. I mean, you can update with over the air, like with Wi-Fi, but that's, yeah, that's native to the IDF. Like that's a core functionality of what the ESP32 offers. There's no reason why it couldn't be done, but someone would have to actually write all that. Like that's, yeah. Yes, not out of the box, I don't believe, but it could be implemented, I'm pretty sure. Hey Mike, what are you doing today? You want to implement that for Shaq? I'm regarded as the biggest underachiever from my school. I'm kind of proud of that. Sure. Yeah, I definitely didn't do what I was told at school, ever. Okay, so, what are we doing today? Well, I got some exciting, well, I don't know if it's exciting, I don't know what's exciting anymore for you guys, or for me. I told you, I haven't had a lot of sleep, I'm very tired, I'm going to mumble a bit. I think I mentioned it, a little while ago, I almost broke my oscilloscope mucking around with the firmware and the FPGA firmware and the operating system. It's really weird how it works, to try to get access, to be able to get a web view out of it. And I got the web view working, and then my scope stopped working pretty much. I was getting really bad results for a long time, and I downgraded it, and I couldn't, whatever, and eventually I got it working. I found a combination of flashing it, and it was all back. And so what I've actually got now, although it doesn't look great, is I can now show you the web view of my oscilloscope. Unfortunately, it's really contrasty, as you can see, and it doesn't translate very well. Especially the rising edges on a graph, you'll see it's super thin. And I can't find any way of changing visually how it looks. It's also really, really, really terrible software. So it doesn't scale with the window, which really sucks. But there is this full screen thing, or this stretch thing. Hey James, just in time. So it was because of James that I did this. Yeah, I got it working. It was because of James, he did this in one of his videos, and so I thought, you know what, I've been wanting to do this for a while, and I went to do it, and almost destroyed my scope. Anyway, if I click this full thing, watch what happens. Great. It goes full, but to the point where I can't resize it, and I lose the window. So that doesn't work, and then when I put it back into window mode, I get this, which is kind of, yeah, really bad. And then I can't actually easily recover from it, because I can't get back to that icon. So it's really crap software. So if I refresh the window, I can then get back to it, to a small screen. So that's the first crap thing with it. If anyone knows a solution for that, that'd be really good, but that's really bad software. The other thing you can do is you can click this little button here, which opens the control panel. So right now I can't click any of these things, but if I open the control panel, right, then what I can actually do is I get the actual controls, and I can actually control it. I have to click these buttons here. Unfortunately, if I do that, I can't size it. See, it gets too big. It doesn't even fit on my screen. I've got this is running off a 5K monitor, and it does not fit on the screen, and I can't size it down. It's terrible. It's really, really bad. So, yeah. So all I can do is leave it this small, and I can't, the contrast and anything, I'll do the best I can. Control plus or control minus, I don't, well, actually, good point. Okay, that didn't work for me yesterday, but it's working a bit better now. Right, it must have been because I was in the full screen one. Interesting, okay. So that didn't work yesterday when I did control plus and control minus to zoom. But it's working now. I must have got it into a weird setup, I don't know. It just means that now this view, maybe I'll put that here. You don't really need a lot of, maybe I'll do that instead. And maybe I can get, the bigger I can get this view, the clearer you'll be able to see, I think. Maybe. I'll push it off the edge a bit. We'll see how we go with that. Okay, what did I miss in chat? Thanks for that, Azzy. I did try it yesterday. I always do control plus and minus on all my windows to get it bigger. No, I'm not writing Oscilloscope software. I can't even finish the software I start. I've said before I got into hardware so I can stop writing software, but I seem to be writing too much software. By the way, my computer sounds like it's going to take off, so I hope OBS behaves itself. So here's the thing. I've been slack with my Reflow Master Pro. So for those who don't know, this is my Reflow Master Pro. This is the version of it. By the way, there's no chat on screen on this side, because if I put chat in, everything, I lose too much space. The scope's connected over, it's a web socket. So this is a web viewer. The actual scope itself has a web server. I can actually, I don't think, I know it's got Ethernet. I don't think there's HDMI at the back of it, no. RMP, yes, Reflow Master Pro. Okay, I just got lost. What was I talking about? Right, so normally it has a screen on it for the output, but I was talking about the chat, yeah, so there's no chat in this view. If anyone wants me to put the chat back, I can. I'm just going to have to make things a bit smaller. Sorry about that, but there should be a live chat on the side for a replay anyway. So this is still my revision 1 board. I haven't changed anything. It's working fine, although I realized yesterday when I was setting all this up that I probably should have stuck some just some pull-ups on the ground side of, like, the relay, for instance, the SSR. I'll go through that in a moment. It all works fine without them, but just to make it complete, I guess. So it's not even a picture of me. You can't even see me talking. Is that okay? Is everyone okay with that? WebSockets are nice if you don't push too much data. Had lots of problems when pushing data in gigabytes. Hey Helmet, and hi to anyone that's popped in that I missed. Yeah, look, I'm only using this WebSocket view for you guys. Like, obviously I can see my own scope, so I don't need to see that, but it's a much easier way of you seeing what's on the scope than me trying to set up an extra camera in front of the scope, which isn't very clear. How do I like the scope? It's your favorite. The scope's okay. Like, feature-wise, it's fantastic. I don't know. I don't think I'm just very good at using a scope. I don't know. I seem to struggle a lot getting stuff working and triggers working properly. As you'll see in a moment, sometimes sometimes what I think should be triggering fine just doesn't trigger. I don't know. I think it's just my brain. So, okay. What was I saying? Right, so what I've got right now is I've got an SSR over here connected just to the back, to the relay port. So I should take these thermocouples off. So the relay connects into here, right, and then there's two ports for two fans that you can control, which obviously there's no code to do that yet. There's no code to control the SSR either right now. And I want to control it with PWM, so that's what we're going to play with today. Hey Robert! So it's connected here right now, and the reason I've got the SSR connected is because it needs a load. Like if I don't have a load on here, I get weird results from the scope. So I'm just going to blow my nose, 1 second. Okay, I'm back. So, by the way, the chat is on the wrong side of the screen for me now, so it's quite hard for me to... I can't see the chat if I'm looking over here, just letting you know. So, what I'm going to do, I'm going to plug it in. Turn it on. It's not going to do anything because there's no screen. Hey, Electronic Smoke. So it's not going to do anything right now, but once it's connected, I can obviously get into MicroPython and get into the REPL. So I can just R shell to it. Well, I've made the font really big. Can everyone read that? It's way too big. If I go into the REPL and just clear the screen, so I can now talk to it, right? I can. Before I connect up the scope, so you can see there's or you might be able to see that's a little LED, right? So I can turn that on and off just by, if I import, from machine, I hate typing live, import, what do I want? I want PWM and pin. So I can say, so that's on GPIO 26. Super clear on your screen? Awesome. Hey Paul! Hey, Hack Pro. Are you a pro hacker or just a hack? Sorry, that was bad humor. So if I can say like pin 26 equals pin 26 comma pin dot out. So I can just set up that pin and then I can say p26 dot on, and you'll see actually, right, and so it's lit up, right, and I can p26 dot off, and it's turned off. So we can see the SSR working, right? That's the DC side. I've got nothing connected to the AC side, obviously, but from a DC side, we'll be able to see that LED change intensity based on what PWM I'm doing. PWM is one of those things I have to relearn every time I want to do anything with it. It never sticks. Yeah, I'm kind of the same. I'm just going to switch back here for a moment. So, see, I'm kind of the same. So I totally get PWM. What I don't get. So duty cycles are easy, right? So clearly, 100% duty cycle means it's full, and 0 it's whatever. It's off, and then 50% is half-half, right? I get all that. Where I really struggle all the time is frequency. Now, on something that requires a specific frequency, that's different. But like, for instance, for something like this SSR, I don't know. Like, I've been playing around with different frequencies. I understand that, like, from an AC point of view, especially with the crossing point, right, on AC, I believe it's 50, is it 50 hertz or 50 kilohertz? I don't know. Like, I don't, yeah, for me, I never understand what I'm supposed to be setting my frequencies to. Yeah, that wasn't explained very well. like, I understand how frequency works. I understand, well, like, a 1 kilohertz frequency is a 1,000 samples a second and all that stuff. But yeah, like, so I don't even know what my mains crossing is. Like, is AC in Australia, is it 50 hertz or 50 kilohertz? I never play with AC. I hate even thinking about AC. Isn't frequency only needed for servos? Well, I don't know. That's the point. Mains is it's 50 hertz, right? Not 50 kilohertz. 50 hertz. Okay, well, there you go. So that's super slow, right? So am I supposed to be doubling it? You're worried about lining up frequency? No, well, I'm not worried about it. Because at the end of the day, you don't have to line it up. All that means is you're not always transitioning at the crossing point, which means it's not as optimized as it could be, but it still works perfectly fine, right? For the purposes of powering a toaster oven, like, you know, it doesn't have to be spot on. For some applications, it absolutely has to be spot on, but for this particular application, it doesn't. But it's still, like, that's where my brain kind of, like, every time, like Mike said, he has to relearn it every time. For me, good morning, Alan. For me, it's like every time I need to stop and go back to basics to try to understand how frequency fits into the equation. Like, it would be much easier to understand it without frequency. Frequency does really matter for this application, as you're not sensing the waves, the mains waveform. Right, but it still doesn't matter in terms of whether the toaster oven's going to work or not, whether it's going to reflow the board or not. You know what I mean? So it just means that it's going to be less efficient, as in it's going to be, like, if I tell it to be at 100%, but my, you know, and I want 100% power, but my frequency isn't matched properly, I'm not going to be sitting at 100%. I'm going to be sitting at a lower value than 100%, right? But at the end of the day, like with a toaster oven, if it's running at 90%, 95%, or 100%, you're not going to get much of a difference in the results, because the issue with a toaster oven is the rate of change of temperature that an oven can match, and not matching the exact power all the time. I know this because I've got my Reflow Master. I've sold a stack of them. I've spent a lot of time with my Reflow Master, and I can tell you for sure, like early on when I was working on it, that it didn't really matter what my frequency was set to on the Reflow Master. At the end of the day, my results were, I don't know what the word is. I can't think of the word. The differences were immeasurable, if that makes sense. Are these SSRs based on MOSFET or Triax? SSR come in lots of flavors. I don't know. I can't tell you what this SSR is. This is a this is not a okay, this is like a Chinese one, but not one of the cheap Chinese clones. This is it's not like a super expensive one like I've got in my Reflow Master, like in my other toaster oven. Well, actually that's not true. This actually cost me more. But it's the one I'm using here is, the one I'm using my Reflow Master is a reputable brand. This one is a no brand that I can see anywhere. But it's not one of those cheap Chinese clone ones. So look, I don't know what's inside it. I could probably crack it open, but I'm not going to. PWM frequency matching can come an issue with some of the PID things. PID makes my brain hurt. Yeah, well, right now, like, PID's a real interesting thing. I don't use PID on my Reflow Master. I was thinking of maybe doing it on my Pro, but I really don't want to. I'm happy to go into that. Later. So lots of chats gone past. If I've missed something, can you just at me again? Yeah, if I've missed something, sorry, just ask me again. What's the maximum frequency SSRs can handle? Whoops, wrong screen. Let's go back to here. I don't know. But obviously, this is like super low frequency stuff we're doing right now. Like, the stuff I've been playing with is, you know, I've actually been doing it at, actually, I don't even remember what frequency I'm playing at, but it wasn't even 50 hertz. It was higher than 50 hertz. I believe. I think it was 500 hertz I've been playing with. So even that's too high, or higher than needed anyway. Hi, in your case, I think it's probably easier to think of frequency as a reference to how much resolution you want for the duty cycle control. Hey, Des Razier. Yeah, okay, I guess that's an interesting way of putting it for sure. I'm just trying to really determine whether it makes much of a difference, though. From an electronics theory point of view, I'm sure it does, right? Without a doubt. I'm not saying it's not important. But from an application point of view, I've not been able to, like when I was trying to tune my Reflow Master, it really made no difference what my frequency was being set to in terms of the results I got. That's all I'm saying. That thing can't switch at 500 hertz. Hey Jay, you don't think it can't switch at 500 hertz? I don't know, it was switching. Or I don't know, again. So trying to switch it to 500 hertz and it can't do it, all it means is it's not going to switch often enough, right? I guess. Thermal mass of your heater elements will counter fast switching on and off. Just use it like a standard relay. Off when temperature too hot, on when too cold. No, I can't do it as a standard relay either. So the way I'm treating it is more like it was an analog write instead, which is basically what a duty cycle does. Like if you've got whatever the frequency is, you've got a 50% duty cycle, you're effectively giving it half power, half voltage, right? So like if I'm feeding this thing 5 volts and I want it to run at half rate, I need to feed it 2.5 volts. I mean, that's how I think about it, right? I kind of take frequency out of the equation. Hey, Kepo Steve. I'm trying to remove frequency out of the equation and treat the duty cycle just like I'm powering it or not powering it, or I'm half powering it, which is how I do it on the Reflow Master, and it works. Works fine. Well, yeah. Is it correct? I don't know, but it works. What's the stream about? Hey, Nathaniel. The stream is about I've got my Reflow Master Pro connected to an SSR. I'm going to put it on the scope, which is this output over here, and start playing around some PWM and see how we can get the SSR running. Element take a long time to heat up. They don't take a huge amount of time to heat up. Well, it depends on the oven. 50 allows no transition. If it takes 10 milliseconds on, 10 milliseconds off, 50 hertz allows no transition time. Yeah, so that's interesting. Like I think maybe through right or wrong, love it or hate it, so far I think everyone here is going into way more detail than I personally think I need to for this, in terms of considering transition times and stuff. What I'm not going to do today is connect it to the oven, basically because the oven's over there. I've got no way of videoing the oven. I have to pull the oven apart to put the Reflow Master Pro in and the thermocouples in there properly, and rewire some stuff, and that's just not going to happen on the stream today. I might do a follow-up video at some point in the future once I've got the rest of the code for this working. I've got no code on here right now that actually controls the SSR, so none of that's in there. I mean, I've got reading the graph, it knows what temperature it needs to get to, but I don't actually have... This is a new oven. It's not a new oven. I was actually thinking of getting a second oven to do all this in, but I haven't. And I don't want to pull apart my current Reflow Master in my toaster oven because I used it, but I also feel like I should use that oven because I know it really well, if that makes sense. So, and I can't get the same oven again. I've looked, I can't find them anywhere. So do you think your Reflow Master Pro would be a good upgrade for the T962? No, it won't replace the control in the T962 because it doesn't do all of the 24 volt stuff, or yeah, this is not a replacement for the T962, although I know someone that's taken my original Reflow Master and connected to their T962A and got that working. I mean, you could technically, but I'm not designing this as a replacement for the T962. That makes sense. Yeah, the response of the triac in SSR will make PWM inputs on the DC side work funny, as it locks on until the next 0 point. I don't know, Paul. It might. The question is, will it reflow a board? So yeah. Okay. So what I'm going to do is going to connect up my scope. Now I'm not looking for a super clean signal on this, so everyone's going to freak out. But I'm going to have a nice big ground loop. That's my ground loop. I'm not really fussed right now about the size of the ground loop, as you'll see. And what I'm going to do is, so I've got a low side switch, so I'm switching the ground, right, which is on this side here, the blue cable. So I'm just going to hook this to the blue. Whoop. Right, and everyone saw the graph went up. Oh, the scope went up because by default, if the pin is on, actually, so if the pin is on, then that switch is being pulled to ground, right? So this is the result of it. And if it's off, then it's going, off, then it's going high. So when it's high, it's actually off in this case because it's a low side switch. So does that make sense? So although technically this is a 3.3 volt voltage, and the actual SSR is running at 5 volts, but that voltage difference is enough to switch the SSR off. And then when it's pulled low, the SSR turns on, and that's at 100% right now. So that's just an on and an off, so it's full, so it's 100% duty cycle, or there's no PWM right now, if that makes sense. Okay, lots of chat going past, and hi to anyone new coming in. Hi, Tero. This will be switching AC on this side, yes. Right now I'm just smacking on the DC side, but yeah. Joints, log. Now being moved past and no contact arcing features, 0 voltage. How did you know that was Ultronics? That was from Ultronics, Peter. How did you know that? Features 0 voltage, or did I say that before? I don't know. Okay, if you're happy with the system taking 1 second to react to 1 Hz PWM is fine. If you want it to react in... Right, so hey Paul, so the thing is, toaster ovens can't switch that fast, right? So as I said before, for the application of a toaster oven, where the bottleneck is always the rate of change of the elements of the oven, then super fast switching on the SSR is not important. Right? Because there's nothing I could do fast switching on the SSR that's going to improve the speed of the oven, right? And improve the rate of change, both heating up and cooling down of the thermal mass inside the oven. So that's why I said before, in this particular application, it's not important. For other applications, it could very well be. Yeah, does that make sense? As rapidly cycling the element is not great, as it may actually vibrate and break. I don't know, I've reflowed hundreds and hundreds and hundreds of boards in my oven with no issues using this exact technique. Yeah, okay, so I'm going to just go back to here. So I need to set up some PWM, so I'm going to just, what am I going to call it? Relay equals PWM, and it's going to be on pin 26, which is the SSR, and so let's set the frequency to 50 hertz, and let's set the duty cycle to, so the resolution I'm using is 0 to 1023, so I'm going to set it just to 512 to give us a 50% duty cycle. What? Hey, Andy Callaway. Max frequency should be like mains frequency divided by 2. I thought it was... might want an inrush current limiter. Okay. Sorry, a lot of chat going past to read. So the conclusion is if PWM is above 25 Hz, then each half cycle of the AC, the triac will be open effectively 100% with PWM. So you reckon I should be going at half, at 25? The zero crossing reference and a PWM frequency of more like 0.2 Hz. Oh wow, okay. Well, I'm just going to start. So as you can see, now I've got a 50% duty cycle. So that's 5 millisecond spacing. A good cool thing is you need less than 1 Hertz. Hopefully give 0 cycle or half cycle or a full cycle only. Only turns off and on at the crossing point. Okay, I mean I can, look, we can go right down. I don't know about what 0.2 of a Hertz. Can I even go that low? Parts of main cycle. I would expect the on time in seconds, not parts of a main cycle. It's a millihertz, 100 millihertz. English muffin pizza. Hey Ed. See ya, good luck with your presentation. So I'm confused about what everyone is, so I'm just reading the chat. Lots of different things flying around. Hey Hojed, what did you miss? So I'm being schooled in SSRs and AC, which is totally fine. That's why I'm here. That's why I'm doing this live, which is totally good. But I'm confused. I'm just reading, sorry. You're not synchronous with the mains, therefore you can't really switch at mains frequency. You're not in sync, target max half for that. Consensus seems to be PWM is probably unnecessary for this versus the old code. Right, but I only have, well, Okay, so this is at 25 hertz, Jay. But people are saying that's way too high. Sorry, I'm still reading. What's the purpose of the SSR in the oven? To switch mains, to be able to turn the elements on and off. So as the graph is changing, to tell it to increase power or decrease power. It's not as simple as just on or off. Is the resistive heating element the best for the oven, or are there other DC heating devices? That's a totally out there question, Mike. I don't know. I mean, the element is the element in the oven. Technical limit of the... Hey David, hey Imagination 2 from... Oh, right, so just pointing out the technical limit. Sure, okay. I mean, I can take this as low as I want. Well, actually, I don't even know, right, how... I mean, that's 5 hertz. Right? I mean, that's having trouble triggering. Set up an opto isolator. I don't have an opto isolator. Yep. Sorry, Peter. Don't have one. Okay, so what's interesting here is PWM might not apply, which is why I don't use it on the Reflow Master. As I said, I use an analog write on the Reflow Master, and I don't care about speed. But there is no analog write on the ESP32. There's that LCD stuff, which is kind of like a hack, but internally that's just implementing PWM, right? So there is no equivalent to what I'm doing in, let's go back to here. There's no equivalent on the ESP32 to what I'm doing on my Reflow Master, which is running off a SAMD21. At the end of the day, an analog write internally still, like on the Arduino side, still might be doing a PWM, I don't know. Hang on, depending on your luck. AC gods. Full cycle. Sorry, I'm just reading still. I don't think I've ever had this much chat to read ever in a stream. Need to monitor the power line. Sure. Well, right now, I mean, so can I just, okay, that's interesting. So as I said before, I don't touch AC. I've never touched AC. Can I connect my scope to the AC side? Can I connect my scope to here? Like, what will that do? Because, I mean, there's not going to be any load on here. Do I need to stick a load on here? I don't have any opto isolators. No. Okay. I think Electron Ash is saying, no, I cannot do that. Hi, Electron Ash. Use a resistor divider. Right. Okay. Okay, well, there you go. Okay, that's why I asked. That's why I asked. That's why I don't play around with AC with the scope manual. Oh, that's really... Yeah, I don't have any specific probes for that here. Ground of mains if attached to active fireworks. Okay, I got it. That's why I asked. I never would have done it. I never would have even considered it. A manual? Did my scope come with a manual? I don't think so. If you saw it was an isolation transformer or battery, you'd be fine. Okay. You're talking, yeah, I was talking about as is. Just to see what the output was. But yeah, let's not do that. Okay, I got the message. No. No, don't do it. Yeah, I don't need a differential probe. Well, maybe I could use one now, I don't know. But normally, I mean, this is, yeah. The way I normally would test something like this, hey Mike, hey Dustin, would be on my oven and see the results, right? Because at the end of the day, all I'm concerned about is, can I get it to reflow and match my curve properly? Like I learned about the ground thing when testing low voltage stuff with an oscilloscope once. If your neutral is referenced to ground, you can easily use a resistor divider made from 3.3 milliohm resistors. Hook up a table lamp or something. I don't have a table lamp, believe it or not. Wow. Okay, there's nothing for me. Sure, you can connect a scope to 1000 volts if you know what to do, and I don't, because I don't play with AC, and I deliberately don't play with AC. You'd be probing the output with no AC attached. Will it damage the scope? I don't know. Okay, let's move on from that. I'm not going to be doing that. So, I guess a question is how low can I go in terms of frequency and still have it? Because at the end of the day, if it's all about dropping the frequency, which I can do, right, and then playing around, I don't know why I keep initializing it, relay.duty, so if I set that to 1023, I should get right, so it's obviously really slow now, which might be okay, maybe not as slow as DigiCoolThings wants. Alright. So it's off. So what's my division? 20 milliseconds. Okay. I mean, at the end of the day, like, it's the rate that I'm changing it. I can slow it right down, it's fine. I don't actually see any need to scope the output anyway. What are you testing? That the claim zero crossing is working? No! Oh, on this side, like, yeah. No, I just was curious to see what I'd see, that's all. I don't even know what I'd be looking for to see if it's working. Advantage of lowering the frequency is the relay will last longer. Okay. Hooking up the low voltage side of a transformer to SSR might not trigger the same way as the mains. Right, so, yeah. So I was curious to know if I hooked up my scope to here, would I see a sine wave, and would I see it line up with the, or not line up, but with the DC side? That's all I was curious to know. Might as well just be banging the SSR on and off with an offset for the thermal mass of the oven. Right, but it's got to be banging it on and off at a certain rate, and that rate has to change based on if I need it to be running at 100% or lower. Right? It's not just an on and off. It's got to be a timed on and off. It's got to be a, I need to be able to change the ramp of how much power I'm sending through. All I'm saying is seconds long on and off cycle is what you want for mains element heat control. I don't know about seconds. I don't think seconds is enough. Is fast enough. Yeah. I know what you're saying, but yeah, I don't think seconds is fast enough. It would, I wouldn't want it switching any slow. I wouldn't want it, running any slower than 1 second, I don't think. Even if at the end of the day that's too fast for the SSR. Temper the heater with your old code. It's just way too slow to react. Right, but my old code, I can't do my old code on the ESP32. So on the ESP32, the only way to do what I was doing before is with PWM. That's the point. At the end of the day, there's no such thing as analog write. There's no such thing as telling a pin to be 50% output. So the only way to do that on the ESP32 is with PWM, which is why I'm playing with PWM right now. No, the rate is not what changes the resultant heat, the duty cycle. I understand the duty cycle changes it, not the rate. Sorry, where did I say otherwise? I don't think I've got any AC transformers around other than anything that's in a wall wart. Sorry. Wow. There's no good reason to alter the PWM frequency once you find one that works. Right, yeah, I'm not planning on changing the frequency. Like, my aim is to not change the frequency. My aim is to change the duty cycle. But where the start of this video, my understanding of what the rate of the frequency was going to be, that's all changed now based on what everyone's saying. Yeah, and so the Reflow Master is using analog write, which okay, underneath might be PWM, but without any frequency control. So I'm not sure what that does internally, but in this case I have to use PWM specifically, right? There's no way of setting up PWM. There's no way of doing this on the ESP32 without actually using PWM and setting a frequency. So I need to use a frequency. So why do you run it at less than 1 Hertz? I'm not worried at all about it. I don't care what I run it at, so long as I care about being able to reflow or not. That's all. It just, going into this, I understood that I should be running at 50 or 25 Hertz. Clearly, that's changed. And I don't care how low I do it. I don't even know if I can set a frequency of lower than 1. I might be able to. Frequency 0.1. No. So it's got to be an int. So the lowest I can do is 1 anyway, for 1 Hertz. So I can't go below 1 anyway. Pick like 10 Hertz max. Like I said before, it'll be infrasonic and less switching stress. Okay, you lost me, Peter. If you run a subroutine at every zero crossing that counts to 100 half cycles each second, your heat setting is the ratio of on cycles to off cycles. 10 Hertz PWM. Hey, Rando. Your PWM won't limit the power without having the frequency cycle much slower than the AC frequency. The minimum length of the smallest plus width being about 1/50 of a second. So I'm currently not planning on using PID control. I don't use PID on my Reflow Master. for a couple of specific reasons. But I thought I'd play around with PID on this, but I don't think I'm going to want to use it. Hang on. I'll get to that in a moment. Division of the PWM. What do you mean, what is the division? The resolution of the duty cycle you're talking about? Duty cycle is, at this frequency, it's 0 to 1024. Note that if you change your timer set up for other reasons, you may no longer be able to get low frequency. Jay, I have nothing else to use other than PWM for this. I'm not sure. What would you use? I need the ability to change the rate. Like, yeah, I don't. I don't think you can divide. I don't need to switch the SSR fast. There's no requirement for that, Dustin. It's just that I started at 50 Hertz, thinking that I needed to be matching what the AC was doing. That's all. There is no requirement to switch it fast, and I can't switch it any lower than 1 Hertz. So there you go. That's where I'm going to sit. Some internal library stuff might mess with you in the future. Well, I've got nothing else that I'm switching. Yeah. Right, but there's nothing else I can use, Jay. Sorry, I'm just... You keep telling me avoid PWM, so there is no other solution on the ESP32. And ultimately, analog write is still PWM. So you keep saying don't use it, but I don't possibly know what else I could be using to control this. Use a binary output. So just do okay, well, sure. I could do a digital high, digital low, and run the rate myself. Sure, but all I'm doing is simulating PWM, so I don't understand what that's going to do. Like, if I need it to be at 100%, I set it to on, and if I need it to be at 0%, I set it to off, and if I need it to be 50%, if I need to slow down the rate at which it's heating, then I need to start playing around with timing of on and off cycles, which is basically PWM. So I don't understand. Don't use PWM, but use digital I/O and simulate PWM. If I use PWM, there may be issues future. I don't know what issues you mean, other than, like, this is an isolated space. Like, nothing's going to be changing anything that my code doesn't change. Like, this is not like all of a sudden, it's has to work with a different system that I don't have control of, and it's going to change. How would it might though? Yeah, I know what bit banging is. Like, but all I'm doing, right? Okay. Sure, okay. Just gonna go back to here. Sorry, I'm still... Timers might get messed with other things like the Python runtime. Well, the timers shouldn't get changed by anything unless I specifically change them. Hey, Rudder, Froxswerg. Sure, I mean, okay. So what you're basically saying is I should bit bang my own PWM rather than use PWM just in case timers are changed internally out of my control, which in this case they won't be because I'm controlling the firmware, and a lot of this stuff's going to be living in the firmware that ships with it, not externally, which means people won't be able to change and mess with it. But if people do change and mess with it, that's on them, assuming that I open source it all, right? So like I'm confused. What I'm describing. Sorry. Hi to anyone that's new that's popped in. Sorry they haven't said. Who are you talking to, Joseph? I haven't described PID at all. Like, what do you mean? Sorry. Right now we're talking about PWM versus bit banging a duty cycle. It's easier to use a GPIO and a timer than to use PWM. I disagree with that in terms of it's easier. Like one line, one command, and I can use PWM. I don't have to write any specific code with a timer. But okay, that's easy to not easy. Maybe in Arduino land or in C++ land, but in MicroPython, like as you saw here, PWM is one line of code. Sure. Jose, right, but we're not talking about that right now. Like I'm not talking about how I determine how long to change the duty cycle or bit bang the data. That's what PID is about. We're not talking about that right now. We're talking about the raw level of replacing PWM with bit banging. That's it. How we control the bit banging or the PWM duty cycle is not what we're discussing right now. That's PID or not PID, depending on how implemented. Right? We're talking about like a step down from that right now. No, you don't want to be messing with duty cycle, and that makes GPIO easier. Wow, so there's a lot of, yeah, interesting. Lots of conflicting information here. And obviously lots of opinions, which is totally fine. Like everyone's clearly entitled to their opinion. Okay, so let's take a step away from the PWM and the bit banging just for a moment. Yeah, I could use a 555. Why am I not going the Arduino way? Because I don't want to write all this in C++. I want to write all this in MicroPython. There's some stuff I have planned for this that is much nicer to write in MicroPython. And yeah, using MicroPython instead of C++ right now. Oven checks the required profile temp every second versus thermocouple actual temperature. If it needs more heat, I switch on relay. Sure, I mean that's what my Reflow Masters do, Hibatronic. I mean, kind of. My algorithm's a bit different to that, but sure, it's turning it on or it's turning it off. But I don't believe full on or full off per second is enough. For my experience with my Reflow Master, my original Reflow Master in my oven, 1 second changing of either 100% on or 100% off would never reflow correctly in my oven. My first one's written in C++ in Arduino. So so going into PID versus not PID. So I'm by far no expert on PID, right? So I'm not claiming that I am, and I know that PID seems like the ideal thing for this, and most controllers implement PID. But when I was playing around with PID at the start on my Reflow Master before I ditched it and implemented my own thing, the problem I had with PID, and I'm sure everyone's going to jump in and tell me that I'm wrong, or you do it like this, you do it like that. The problem I had with PID is there are parts of a reflow where you don't want it to be following how PID works. Apart from the whole fact that, PID is only good if you've got the correct values tuned, and to get the correct values tuned on one device, on one oven, doesn't make it work on another oven, and so then you need to design some elaborate calibration system that allows it to work out what the correct integral and derivatives are for each particular oven, and then how do I test that unless I go out and buy a whole bunch of different ovens to be 100% sure that my calibration system works, and all of that crazy stuff. All that aside, right, which I think is just a lot of work. The problem for me with PID is always, unless you hack the way PID works. So let's take a step back. What my algorithm does is, I don't know, I'll put this on paper. If you can't follow, I'll put it on paper. So let me know if this makes sense or not. So I'm not looking at a particular time, right? I'm not looking at what temperature do I want and where am I and what do I need to do to close the gap, right? Because a toaster oven can't change that fast. So what I'm looking for is, where do I want to be in the future? Okay? And not so much where do I want to be in the future, but what is the graph doing in the future, right? So in the future, let's say 7 seconds away from where I am now, is my temperature higher or lower than where I am now? And is the graph rising or falling, or is it straight? What I want to know is not where do I need to be in the future, but in the future, if I need to be there, am I on a decline or an incline? What is my delta at that point? Because I don't want to be matching a temperature, I want to be matching a direction that the curve is going. And PID can't do that. Now, maybe someone here can tell me that PID can, and you need to do blah, 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 possibly, but that's not what PID's designed to do, right? Sorry, let me rephrase that. I shouldn't say it's not what it's designed to do. I don't know maybe it can, but I've not seen PID implemented that way. I've never seen a solution that can do that in PID, other than, sure, I can tell that my endpoint, like where my target, I can pick a temperature from the future, sure, but that's not the same. I don't want it to say, I'm at 50 degrees and I need to be at 70 degrees in 5 seconds. I don't need that. What I need is, I'm at 50, I need to be at 70 in 5 seconds, but it's going to be going down to 60. So don't ramp up quickly. Don't go full to get to 70 because I'm going to overshoot. Does that make sense? And I could not get anything like that working in PID. And as soon as, yes, there are PID filters, there are all sorts of things you can do, but that just really overcomplicates stuff, right? So I came up with what looks like really ugly code, but what it does is basically it has a look ahead and it's working out the delta of what the curve is doing in the future, and if it's above and below, and then it's adjusting what it's doing accordingly. And I've got really accurate reflowing. like really accurate, you know, for a toaster oven. And so my plan is, like, I've already implemented that in MicroPython for my Reflow Master Pro, and I think that that's the direction to go. But I'm prepared to look at PID again, just to see the WH2, the derivative term in the PID does. See, exactly right. Sure, Shaq, it does that, but it doesn't do that. Like, because that D is different for every oven and for every oven's capability. And so how do I know what that is? Right? It's not that simple with PID. Oh, that's what D does. I've had people tell me that before. That's what D does. Well, that's great. But I need to hack D. What do I do with D to make it do that? Is the question. Because D is not just like D has to change all the time. It's not a single value. There is no single value that D can be. So I could tune my oven specifically eventually and get the values right to do what my oven needs to do, but it's not going to work on another oven. So that's how I'm doing it on my original oven, Dustin. Like with my original Reflow Master, I'm using my algorithm, right? A self-tuning PID. Right, and self-tuning PID means what? How do I do that? I get self-tuning PID working on one oven, but it can't happen during a reflow. It's got to be a calibration system, right? And then I have to go out and buy a whole bunch of other ovens to test that my calibration system works on all the ovens. Because I can't ship a product that's been tested on a cross-section of one. That doesn't work, right? Where my algorithm doesn't need any calibration at all. My algorithm is going to do the best that the oven can do every time, no problem. And the only thing I need to expose to a user to change is the look-ahead position. So for someone that's got an oven that can change temperature faster than someone else, they don't have to look ahead as far if they don't want to. So there's a setting where they can change the look-ahead value. And that's the only value that needs to be changed in my algorithm, and it doesn't even really have to be changed, right? So the downside to my algorithm in my current implementation on the Reflow Master is sometimes it has a problem when the graph isn't changing, when there's a flat bit, right? So it's doing pre-soak, and then it goes flat for a bit, right? That flat for a bit can be a problem on some ovens, but I've got a solution for that for my Pro. Okay, jump back here. So what the triac stuff means is that mostly your SSR is effectively on most of the time when your PWM is on above setting on the present one, let alone. So I'm not sure what that means. To keep the approach algorithm you already have, use I didn't use PID either because it was too hard for me. Right, every printer can do PID on the bed, sure, but every prusa is the same. I mean, give or take slight variances in the yield of the heat bed, for instance. At the end of the day, the settings for a Prusa Mark III is the settings for a Prusa Mark III. That's great. What's if you bought a Prusa Mark III, but you had to supply your own heat bed, and there was 100 different heat beds available, and you don't know which heat bed people are going to buy? All of a sudden, all the tuning that Prusa put into making their values for PID perfect for the heat bed goes out the window, right? So yeah, that's the problem I've got. They're toaster ovens that are not designed for reflowing, and there are thousands of toaster ovens out there, and I've got no control on what people buy, right? You need some friendly customers for your proof of concept. Yeah, I wouldn't want to rely on my product being viable by having to send a whole bunch of non-verified solutions out there for people, friendly people, to go and test on their ovens. Like, that's, yeah. And even if I did that, how many would I have to send out for how many different ovens? Like, it's just, I don't think so. The heat change rate is so slow that you don't need a fast PWM cycle. I agree. We've all established we don't need fast PWM. The slowest I can go is 1 Hertz, so that's what I'm going to have to play with. Can't you add part of the code that does machine learning? I possibly could, Capo Steve, but again, I'd have to write that. I have to then verify that on every toaster. Like, how many toaster ovens do I have to verify it on? Like, coding up a calibration system that I can only test on 1 oven is a really bad idea. Let's get past Peter. Sounds clear to me. Algorithm is good. Perhaps you only need a cal run without product in oven. Right, but I don't know what a calibration run would do. What would it change? Because depending on what you put in the oven is going to completely change the thermal mass of the heat, right? And so, you know, running the oven without something in there and then me putting 4 panels in my oven and trying to reflow, I'm going to get completely different results. So, you know, especially with blackboards that suck in so much heat, you know. So I don't have I don't do a calibration run at all on my current Reflow Master. Every China printer can do auto PID with the same firmware. Sorry, there's just so much chat. You run the built-in auto calibration. Right, you run the built-in auto calibration, but that's on, again, it's they've written that to work based on one design, and it's been tuned to work, and they've tested it on their Mark III, and it works on their Mark III, and they sell their Mark III. They don't have 1,000 different printer types that they sell that they have to make that auto calibration system work on. Anyway, so the old Reflow Master, it doesn't have a calibration. It's got a test thing, which basically it runs some ramping timing and some cooldown timing to let you know how capable your oven is. But that's different to tuning the reflow, right? You know, at the end of the day, if someone buys an oven that's got 2 elements and it's too slow to heat up, it can't. Its heat change of rate isn't fast enough to even reflow a low temp paste. That's what that test does. It says, sorry, your oven's not fast enough. But I was never able to grab that and come up with a value from it that made any meaningful use in my algorithm. Oh wow, I missed a whole bunch of chat. I haven't been scrolling. What's the max error in temp that you expect? I don't know. I couldn't possibly tell you because I don't know what ovens people are going to have. The range of capabilities on ovens is massive. Totally massive. Firm with chamber controllers avoiding PID using derivative of fuzzy logic and achieve 95% of tuned PID. Yeah, look, I don't believe PID is the solution for me here. And my algorithm works. And is it the nicest algorithm ever? Maybe not. I've got some improvements to do on my Reflow Master Pro, and if they work great, I'll roll them back into my existing Reflow Master. But yeah, I don't think PID is needed here. Right, but my algorithm doesn't need continuous calibration. That's the point. The whole purpose of my algorithm is it doesn't matter what toaster oven you connect it to and what its capabilities are. It's going to, whether it matches the graph or not is purely based on the capabilities of the oven, right? So, like I tell people all the time who are wanting to buy a Reflow Master and ask me about ovens is a Reflow Master or any reflow controller can't make your oven do something it can't do, right? If your oven can't heat up fast enough, no matter what controller you put on it and what software you run, it can't make it run faster than 100%. Okay? Can't do it. And so that's what my algorithm assumes, that it's going to, like, it's going to do what it does, and if the oven can't get high enough to match the graph, then that's on the oven. There's nothing, no software change could possibly fix that. Does that make sense? So therefore there's no calibration needed. It does the best it can do regardless. Yeah, I hope that. I understand what you meant by the max error as in the max temperature. Well, none. Like, I don't want it to, like, my algorithm really doesn't overshoot at all. And undershooting is purely to do with, as I said, with the capability of the oven. So I don't really have one. Get what you did in your algo and why it doesn't benefit from calibration. Cool. Resolving problems you have a good solution for is a great way to never finish anything. Absolutely. So is taking my working C++ code and rewriting it in MicroPython. That's also a great way of never finishing anything. I just thought I'd bring that out there too. Be interesting to see the AC after the SSR on your present RM, just to see what effect PWM to the analog write has on the SSR in practice. Sure. Again, I wouldn't even know how to hook that up. Maybe I'll get Alan, if he's watching, to come over. I never want to touch AC. I'll get someone else to do it for me. What does PID stand for? It's the three variables. What is it? I can't remember what PID is. I is integral, D is derivative. And what's P? Process? No, I can't remember. But it's three variables that basically give you the ability to... It's for... To adjust a controller to match a particular thing. Yeah. Do your ovens use fans to accelerate cooldown? Well, yes, my Reflow Master does if you've got an oven, if you've got a fan connected to it, and my Pro has the ability to run 2 different fans, or technically 2 anything, right? So, you could have a solenoid connected to one to push a door open if you want to try to hook that up, and a fan. The software that I'm going to be supplying is just going to be controlling fans for cooldown. P is proportional. Thank you, Paul. Or porcupines. Yeah. Oh, Dustin. What is? Oh, and Peter said it. There you go. I missed that in the chat. Thank you to all that answered that question. The duty resolution can be lowered down to 1 bit. In which case the maximum frequency is 40 megahertz, but only duty cycle 50 available. Sure, all the way up. That's at the highest end, Jay, and at the lowest end, you get I think up to 13-bit resolution on the duty cycle when you go down to the low frequencies. Potions, incantations, and damnation. That's really funny. What is the magic algorithm that does not overshoot and has a perfect... Oh, it's my algorithm. What do you mean? What is it? I just explained what it does. So, you can call it magic if you want. What? Is Mr. Watts here? What did I miss? The oven linear algorithm in my Control 3 seems to do pretty well. Maybe take a look at what they've done. That's not open though, is it? The Control 3? How would I look at what they've done? Hey Dean, support Tiny Pico from Pomeroni. Not had a chance to play with it yet. Cool, awesome Dean, thanks. Peter obfuscated, better use GPIO. Ah, Jay. Sure. I mean, it's the least of my worries. Like, I could use RMT on the ESP32 and bit bang the data out that way, but yeah, I don't need to do that. Hey Rob, got really confused at work when people kept asking me for the PID project initiation document. Hey, that's really funny. A go must monitor temp change over time versus duty cycle and applies according to needed profile. Sure, I know what it needs to do. Oh, Mr. Watts is here. You've been lurking. Hello. Hey, Ross. There's been a great deal of work in PID auto-calibrate functions in the drone world. Possible. Look, I can, as I said, I've started looking into PID again, right? And I wouldn't be doing that unless I was prepared to see if I could get something functional. But I'm still not sure what PID would give me anyway that my current algorithm doesn't, other than make it even more black box, right? Because that's kind of what PID does. Like, you know, PID is designed to be, I mean, obviously you can look at the code inside it, but it's designed to be just a box where you don't worry about the box and you feed it the data, you tune some values, and you get the data you want out the back. And that, yeah, I don't know. That doesn't kind of sit right to me. For this application anyway. Yeah, David's slide display thing. Yeah, he showed that on, was MakerCast previously. Yeah, that's really cool. Looks awesome. It would greatly help with various different ovens and ramp time. Possibly, but I'd still need to, again, if all the software was perfect, I'd still need to go out and have to buy a bunch of ovens to prove it's working before I'd be prepared to ship this thing, right? Like my current Reflow Master, and if I implement Reflow Master Pro the same way, I'm 100% confident of how it's going to work on any capable oven. But if I went for something else that used some form of auto calibration system, no matter how robust it is, I couldn't, within good conscience, ship the product unless I've proven to myself that it works on a very large cross section of ovens, which is a very expensive exercise for me to do, to go out and buy a whole bunch of ovens and hook them all up and test them all and run them all through their paces, right? And that's just going to massively increase the cost of the product. So I don't want to do that, right? If I can avoid it, going back to the sequence frequency any faster than 100 Hertz will be basically negated. Sure. Basically made an auto-tune PID. No, I have all my algorithm. No, I haven't. It's definitely not an auto-tune PID at all. Both Marlin and RepRap firmware does PID tuning for all kinds of headers. Sure, look, yeah, I could go digging through code and try to see what they're doing, but AC headers only greater than 50 Hertz for this. Hey Milosh. Hi Marcel, sorry, I don't speak, I don't know. That doesn't look like German, is that Norwegian? No, I don't know, sorry. Does the auto-tune PID mean the oven can sing like Kate Perry? I don't know. So this stream's gone in a direction a little bit different to what I'd planned. My plan was to actually sit in MicroPython and actually implement this, or start implementing this. But instead it's turned into lots of chat about PID, which is totally fine. Chat about PID, chat about SSRs and PWM. Open the package. Oh yeah, the package, thanks for reminding me. Okay, so look, shall we move on from this now? That was your first problem. I had a plan. Well, a loose plan, like, you know, as far as plans go. Okay, let me go get a package. I need to cross my name out. I haven't blanked my name, but I want to show you the package. You'll see why in a second. Wow, you got my address everywhere. Okay, so I got this package from Radomir, Dishepu, you might know him as. We did a swap. I just wanted to show you, this is how it turned up in the mail. This is how it arrived. Pretty good, huh? I'm glad no boxes fell out, because look, it just falls right out. Like that. This is how the mailman handed it to me. So that's pretty cool. So there were 2 boxes. Let me just move this out of the way. I'm just going to let me shut this PWM down. And off. Unplug. Turn off my scope. Shutting down. And let's switch cameras. Okay. It's going to be a bit out of focus. I'll focus it in a sec. Oh, that's actually not too bad. That's not too bad. Had stuff run over by a forklift. That would have been completely flat then, right? Yeah, I don't need 13-bit resolution at all from a PWM. It's just what it goes, how the ESP32 works. The higher the frequency, the lower the resolution. I got a half a postcard once. Really? Wow. Hey Julian, just in time for the unboxing of some stuff. So, I don't know which one's which. One of these I know what it is, and one of them I don't. So the swap we did was Tiny Pico for a one of his pew pews. What's it called? Yeah, which is one of these. Could be this one. But I sent Radomir 2 Tiny Picos, so he sent me a surprise in response. Sorry, chat's on the wrong place for me to see. Maybe I can see it better if I move it over there. Cool. So, this one is... I think this is the... Oh, no, it's not. Oh, wow. Okay. So, let's zoom out a bit. Oops, I said out. I'm going to just open them both up. Oh, wow. Oh, and a badge. 3 things. I got sent 3. That is a really big clip. So I've got a badge. Do I have a battery? I'll find a battery somewhere in a moment. And this is the Pew Pew, and I believe this is the M4 Pew Pew. Does everyone know what a Pew Pew is? So a Pew Pew is a little like a game controller that Radomir designed. So I'm just looking in the chat. So this is like a little game controller that you can flash games on, and I believe this is the M4 one, and you can't see, but inside here, obviously I can't get them off. Inside here is there's an M4, I think, and some other stuff. And I believe this is let me get some power. Just need a cable. I don't know if I can power from this. That'll be interesting. I don't have a hub on this side, but I'll try. I'll try plugging this in. But I won't blow it up. On. Yeah, no, I can't do power from that port. Let me just find a... Let me get a cable I can put power on. This one? Okay, this one I can do. Okay, I hope I haven't... On? No? Nothing? No power? I thought maybe maybe there's just no code on here. Interesting. Don't know if I've got any AAA batteries. Okay, we'll look into that one in a second. And then this is one of Radimir's. Oh, this is the PWM4. Right. So this is a different PW. Is this the original PW? Wow, I have no idea what I'm talking about. This is the M4 PW. PWM4. It's got a buzzer. It's got an M4 on here. Look at all the acrylic. Wow, nice. I'm just going to take all the acrylic off for a second. So maybe this one power up. Switch. Okay, this one powers up. Oh, look at that. Now let me get, okay, you might not be able to see this. I'll get closer and let me focus. And I need to turn the brightness down a little bit once it zooms back. That's the watermark on the cover of the screen. Can everyone see that? So, look at that little finger moving. So it's a little game console. And it's got sound. So what's that? Invaders, Tetris, Jumper, Snake. Let's go Invaders. Is it O? Oh, cool. Doesn't seem to be any sound. Game over. I died. How do I restart? Here we go. Oh, I died again. I think there's some sound. It might be really soft. How do I get back to the menu? On paused. Okay, I don't know how to get back to the menu. I'm just going to switch it off and back on again. Jumper, Snake, Tetris. Tetris. Look at that. Oh. Actually can't see through the view. Oh. Anyway, cool. So that's what I got from Radimir. So there's acrylic that goes here and here. Like that. Let me just zoom back out again. And then that goes over the top. No. How does that work? Or is it one or the other, maybe? No. How do I get to the buttons? I can't get to the buttons if I do this. I'm not sure. I'm going to have to ask him and find out. That's really cool. And they run off batteries as well. They see what I'm building. It's a really long-winded way. Who made? So so Radimir made these. Dishipu. Let me just go to. I'll go to his website and I'll show you. If I can. pew.read .io. Okay, and if I switch to here, so this is the website, the Pew website. So he's made a few. So it's Radimir. Does anyone know what Radimir's website is? Just his general website? No. Anyway, so the M4 is the one I was just playing with. So hardware specifications, 160 by 128 TFT, SAMD51. Here's the repository for it. So it's all loader. It's all the acrylic stuff. I don't know where Radimir's website is though. If he's got a website. Does anyone know if he's got a website? I'm missing all this chat you see on louder today. I might just be closer to my microphone. I must have been closer to my microphone then. I don't know. No one knows what Radimir's website is. Let's look up Radimir. No. GitHub. Let's go to his. Oh, here. Oops. It's on Hackaday. Is this? Okay. Anyway, he's written a whole lot of stuff up on Hackaday. So that's the Pew Pew standalone. So he's made a whole lot of game controllers. There's the U game, the Pew Pew M4. Oh, thanks, David. Yep, I got it eventually. And then also, let's move that out the way. So Christian Walther, I think is how you pronounce his surname, has done this. 1 second. If I can find here. I'm just going to open. Yep. Sorry, 1 second. So this is exciting. So this is the Pico Pew. So it's part of the Pew Pew family, but the Pico Pew uses a tiny Pico. So these are going to be available soon. Christian sent me one. He's just got the docs together, and he's going to be selling these, I believe. I hope so. And it runs off a tiny Pico. If I go to the assembly page, as you can see here, so there's a tiny Pico on the bottom, upside down. So interestingly, he's used low profile female headers that go on the tiny Pico side. He's actually promoting I'm promoting my product. Haha. So the way it connects, so it means that you'd need a tiny Pico that's already got no header pins on it. He's done that because of size, to get it thin, and then he's also got a 3D printed case, optional case for it. And so this is a Pico Pew. So there's quite a few Pew Pews around now, and so Christian did this. Worked with Radimir, I believe, or he did it himself, but yeah, worked with Radimir because it's Radimir's thing. So that's really cool. There's Pew Pews. I'm gonna have some fun with the Pew Pew. I need to find a battery for this badge. Let me see if I can find a battery for the badge. I want to see what it does. Okay. Oh, let's just switch. I wonder if the badge uses PWM. Haha. Okay. in, and oh, there we go. Oh, how cool. It's a heartbeat. Can everyone see that? That's really cool. So is there any like a thermistor or anything on it that changes its rate? I don't think so. So I can't, is that a 80 tiny, maybe is it a 13? I can't see in this light which one it is. Yeah, this is it looks like a hair clip. It's a really big clip. Why is it not opening? Okay, yeah, that's a really, really big clip. Yeah, it's a hair clip. So I guess it's, I mean, I don't have long enough hair, obviously. Maybe I'll give it to Orly. She can stick in her hair. But it's pretty cool. I'll let it run. Use it for a tie clip. I guess it could be a tie clip. Look at my hair. I have to grow my hair a little bit longer, I think, to fit that in. Is it using row column LED driving? No, I think it's using Charlie plexing. I think it's definitely Charlie plexing, and it's got some. Let me just go back to here. It's definitely got some interesting routing. So coming around here, and then if you look at the this snaky type routing on the top to get to it, but it looks like to me like it's all being Charlie plexed. It'd have to be for this many. It has how many? 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20. 20 LEDs off an 8-pin micro. And the micro is going to have at least, like it's going to have maximum 6 pins available if reset's not used. So that's pretty good. Charlie plexing is very, 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 very clever. So my plan, I guess, now is to implement this, to start with, the 1 hertz PWM, and get my algorithm finished off and get this connected to probably to my current oven. I'll see if I can do that without pulling too much of it apart, and get a proof of concept working. And if it works and it does what I want it to do, I can always go and bit bang the data instead of using PWM, no problem. At the end of the day, it really makes no difference to me which way it goes. I'm not overly fussed using PWM. I get Jay's concerns about what's if something changes with timers, but can definitely bit bang on myself if I need to. But right now, I need to get a proof of concept working. How are things going with the pick and place? Yeah, pick and place is great. Yeah, all the bugs are ironed out, and it places reliably every time now, which is really good. I can go and stick a tiny Pico board on there, and depending on what if I've taken components off and put other ones on, I need to obviously go and tune the pick positions again on the tape on the feeders. But once I've done that, especially if I've moved from a 0603 to an 0402 or whatever, then yeah, it's reliable. It's good. Well, it's as reliable as it can be. I mean, there's always a couple of weird things on a panel sometimes, but it's 99%. So it's good. Yep. Would I want to go through that process again with a pick and place machine? No. If I ever get a new pick and place machine, it'll be something very different. Any thoughts on OpenPNP? OpenPNP is great. Way better software than what comes on my Charm High, but right now, OpenPNP on the Charm High, the only way to do that is to switch the controller out, which means pulling the whole machine apart and rewiring, or reflashing smoothie on the existing controller, which you can't go backwards. So it's a one-way road, and my pick and place is too reliable the way it works right now to go and do that. I'm gonna keep it as it is, stock, and if I get myself a new pick and place machine at any point, I'll probably sell this as it is if I can find someone that wants to buy it. Bit banging is a term I personally think doesn't apply here, but okay. Okay, yeah. Well, it's still bit banging, but I'm doing it based on time, not based on banging 0.000001001. I'm changing the value high and low based on time, based on the requirements, based on time, right? It's still technically bit banging, I think, but yeah, that's okay. I've not seen OpenPMP run anywhere near as fast as yours. On a charm high, you're talking about specifically, Ross? I don't know. I've not seen anyone actually successfully run OpenPMP on the charm high. Well, I know there are people using it and playing with it and experimenting with it, but in terms of production, I've not seen anyone actually. I've not seen any videos of anyone running OpenPMP, like actually cycling through boards. Be fun to make a DIY oximeter with an ESP. What is an oximeter? Do I know Library? No, I don't know. What is Library? Is that a video platform? Sure. I get bit bangings when you're implementing a protocol or sequencing of data. I get that, but you're still basically in a loop, right? Whether it's a closed loop, as in or whether it's just a general runtime loop, you're still, based on some requirement, changing a high and a low state, right? So, yeah. Let's call it bit manipulation then, instead of bit banging. Video platform. Yeah, there are lots of platforms out there now. I don't know. I don't have enough time to even get YouTube videos done, let alone trying to get my videos elsewhere. Yeah, it's by Pied Piper. It's using middle out. Cool. I'll check it out. Yeah, I knew Julian was on there. I didn't know James was on there too. You don't need time. Is there a tool where you can push the videos out to everywhere? My biggest concern would be segmenting. Would be diluting viewers. Like anyone that watches my stuff on Library won't necessarily watch it on YouTube, which means my view count goes down on YouTube, which means my help from YouTube, which isn't much anyway, goes down. Yeah, it's auto. Okay. I could look into it, but yeah, as I said, it's... I'm on there too, just with one video. Cool. Well, that's one more than me. I wonder how my kids are doing. School started, it's 9:30. Library's tiny, nobody knows about it yet. Good night, Paul. Thanks for your help. Thanks for your input on the SSR stuff. Thank you, everyone. Like it was, I'm sorry I spent a lot of time in this stream reading, but it was important to go through what everyone was writing. Yeah, very, very helpful information from all of you today, and I really, really appreciate it. It was really good. I learned a lot. I learned that there's a lot I don't know about SSRs and AC, and I'm happy not knowing about AC. Yeah, it does have a lot of depth. I mean, we've discussed SSRs and stuff like that a long time ago, I guess, when on a stream a year ago maybe or something, when I was playing around with Reflow Masters. Put an SSR channel on Discord. I could. Yeah, okay, I might do that. Well, there's already Reflow Master ones there, so maybe we could just discuss it in there, I guess. There is a MakerCast next weekend, and it might be Brian hosting, but we haven't 100% confirmed. So check out, just watch Brian's channel. I think he's going to be hosting. And I'm not sure who's on yet. I might be on. Who else? Arturo might be on, but I'm not sure. Yeah. On the Topic SSR, I run 2 different ones on 2 large-scale 3D printers. It's not as scary as it all might seem. Oh, the SSR stuff's not scary for me. It's just the AC side. No. No, if anyone's ever going to electrocute themselves playing with touching AC, it's going to be me. And I just know that's just me, so no. Sticking an SSR, connecting it to my toaster oven to control my reflow is as close as I get to playing with AC. With me there, what? Wouldn't it be easier to create a MakerCast channel? Oh right, Julian doesn't touch mains either. Yeah, it's just no. There's a whole. Not only is it dangerous, I mean, sure, if you know what you're doing, maybe not, but it's a whole world of knowledge to learn there that I just don't have the headspace for. Yep. Oh, for goodness sake. So apparently that was just too much drama for you, was it, GN? About how dangerous AC is? As I just said, if you know what you're doing, then that's fine. I don't, so I don't play with it. And I don't really have much desire to learn. I've got enough other stuff that I want to learn. Why is main scary? Okay. Yeah, okay. I'm pretty much sure I don't have to answer that. For someone who doesn't know what they're doing, I think it's pretty obvious why mains are scary. GN, you might know what you're doing, and so you might just take it all for granted. But, sorry. For someone that doesn't know what they're doing, it screams danger. MakerCast channel, because the whole idea is to promote all of our channels, so that's why we do a round robin. Otherwise, we might as well just always have the same person hosting it. Yeah, I don't think a MakerCast channel makes a lot of sense. Yeah. No, we're happy with the way it's going, I think. Yeah. So, I think that's it for this stream. Got a video coming out on Friday that some of you might find interesting. I hope. Fear of mains is a constructive thing, but I only got 500 volt Jacob's ladder running next to me. It's a... Look, fear of anything that you don't know, right? Or you're not comfortable with. It's not a fear of, or what's if I don't know how to do this? Like, there's a risk involved. You know, when you make a mistake with DC and ICs and stuff, you run the risk of blue smoke and damaging your hardware, right? When you make a mistake when you're playing with AC, you run the risk of hurting yourself. So, you know, they're two very different things. Yeah, I'm glad you're playing with that, Peter, and not me. Hate sync on a DMAC receiver. Well, that's one way to learn Electron Ash, I guess. Okay, I'm going to wind this up. Thank you, folks. It's been great. As I said, I really appreciate everyone's... You need an alternative to the 11115. I don't know one other than the 1015, which is 12-bit. Yeah, they're not easy to use, ADCs in general, so I'm not sure how you'll achieve easy to use. High voltage AC. Yeah, you don't need to make the distinction for me, Andy. Like, I'm clear why I don't want to play with AC and why I think it's dangerous, but I get why someone who plays with AC all the time and is comfortable with it would think that it's not. Just like someone who has pet snakes and handles snakes would think that snakes are fun pets and are not dangerous, and then someone who doesn't would think that snakes are dangerous and they don't want to be near them and they don't want to get bitten by one. So it's the same type of thing, right? It's fear of what you don't know and don't have the skills to do. Well, Julian, if you prefer spiders, you should come to Australia. Really. But Ian, that's the same as saying that like a daddy long leg spider is one of the most dangerous spiders on the planet in terms of its venom capacity. But the fact that its pincers are so thin they can't break your skin, right? So deadliest spider in the world, but isn't able to bite a human. So there you go. 6-volt AC is safe. 240-volt DC is lethal. Right, but there is no 6-volt AC around my house. It's all 240-volt AC. So, yeah. Anyway. What's the urban myth? I'm not touching AC. I don't care. That's it. I'm not playing with AC. And SSR is as far as I'm going to go. Anyone? Anyway, thank you all. Thanks for joining. It's been a blast. I will catch you all next week. I might see you on MakerCast. So it'll be this Sunday night for you all, my Monday morning. And yeah, I believe it's going to be on Brian's channel. And on that bombshell. I'll send you some spiders in the mail, Julian, just so you can, enjoy the Australian spider thing. Okay. Catch you later, folks, if I can find the off button again. It's always the same, every time. But, is it there? No. There. No. No. Oh, there it is. Okay. Catch you later, everyone. Bye. Have a great rest of the week.